Okay, so in this video we're going to do a couple of examples, the first of which is shown here. So we have a function f of x is equal to 2x plus 3, and we have a sketch of this function here. First of all, our job is to determine the equation of the inverse function. So, to do this, we need to write out our original function and rearrange it until we get x equals just as we did in the previous video. So I'll take off 3, and I will divide by 2, and now I can just write in place of x, f to the minus 1 of x, and in place of f of x, x. So this means that our inverse function is x minus 3 over 2. So that it's easier to write it in gradient intercept form, I get x over 2 minus 3 over 2, so a half x minus 1.5. And you'll see that that will go through minus 1.5 on the y-axis, and a half x will have a gradient of a half, so if I start from here, every time I go along 1 I go up a half, so it'll kind of be like this, and then if I extend my line like that. And you can see that it's kind of twisted our original f, which you should have expected because of the transformation of this function. However, something to notice, if I put in a dotted line here, if I put in a dotted line through y is equal to x, let's see, that looks about right there. And then I'll extend that down here. Then you'll notice actually that f to the minus 1 of x, which is this one here, is actually a reflection in the line y equals x. So the graph of the inverse function is a reflection of the original function in the line y is equal to x. And this is something to note down and add to your notes on inverse functions, because this can sometimes help you to answer questions more quickly. So if we move on to our second example, we're given another function here, and this time it asks us to sketch the graph first. So, if I have my line of y is equal to x here, then if I reflect this line, then what happens is, if I take a point here 4, 0, that just means that it will go to 0, 4. So actually here, I'm expecting the inverse function to be the same as the original function. So I'm expecting the inverse function to be equal to the original function, because reflecting this in this line, if I put a mirror along this line and saw that in the mirror, I would just see the same on the other side. So let's see if this works with the equation by answering B. So if I add x, I get f of x plus x is equal to 4. I take away f of x, and I get x is equal to 4 minus f of x. And then I replace them, so I get f to the minus 1 of x is equal to 4 minus x, which is equal to f of x as we expected. And we can check this. If I do f of f to the minus 1 of x, then I've got f of 4 minus x, which is 4 minus 4 minus x, which is 4 minus 4 plus x, which is just x. So it's true that these are inverses of each other and they are the same function. And that can happen sometimes, and that's why I put this example in to show you that that can sometimes happen. And an easy way of checking is to draw the line here if you have the graph and try to reflect it in the line y is equal to x. Let's do another one. So here we're given a function that's a little more complex than anything we've looked at so far. So let's first of all sketch the graph by reflecting in this line y is equal to x, which isn't so easy to do, but we can give it a go. So if we imagine we have a mirror lying across this line, then to get from this line here to there, we have to go, let's say, along 2 and up here, 1, 2, 3, 4. If I go along 4 and up 2, I'm going to start here. And I can do the same over here. Here I can go 1, 2, 3, 4, 5, along 5 and down 1, which means along 1 and down 5. Like this. And so I'm going to end up with something that kind of snakes. So I'm going to get closer and closer to the y equals x here, and it will meet whenever it meets. So it'll meet wherever it meets and go something like that. It has some bumps in it, but we have something that's been turned like this. So whenever a line crosses this reflective axis, this axis of symmetry, your inverse function will also cross the axis of symmetry. So I've sketched the graph. Let's determine the equation. So f of x is equal to x cubed. Then to get back to x, all I need to do is take the cube root. So the cube root of f of x is equal to x, which means that the inverse function is the cube root of x. And I've sketched this graph on Desmos for you, so you can see that actually, yes, it does do this kind of lengthened S shape. And we were kind of right with our sketch of this graph. It's just a case of seeing how you would get to the line and doing the reverse on the other side. Sometimes tracing paper can be useful to try and mimic the shape of the graph. But we'll have a little bit of practice with this, and this is about as complex as it will get with reflections. So this one's done. Let's try then something different that challenges us in a different way. First of all, I just would like you to note this down, that the graph of the inverse is the reflection of the graph in this line, and you could note to yourself that this could be referred to as the mirror line, to remind yourself to kind of put a mirror along here. And we can see with this example as well, whenever it crosses, the inverse function also crosses. And if this were to carry on, then this would carry on like this. So, here I have a graph, and we need to find the inverse. So, if we had y equals x going through like this, then it's going to cross here and cross here. What would it look like? So that's going to be kind of like that, and it will kind of go through the mirror line, it'll come back to the mirror line, and up like this. So C is going to be our solution here. This is going to be the inverse of our function if this were f of x. Next one, try it yourself before I give you the solution. So, here we have this function, here's the mirror line. Oh, unfortunately we've lost our red, so it would cross here, and it would kind of go up like that, and it would get further and further away. So, it looks as though B is going to be our solution. Hopefully you paused the video and found that out for yourselves. So that's all I wanted to show you in terms of inverse functions. We'll do a little bit of practice of it next week in class with some of the exercises from the IB book. If you have any questions, as always, note them down and please ask them in lessons.